Good day to my evaluators. My name is Ko Leong Chen, final year network and security student. Today, I would like to present my final year project with the title Application of Knowledge-Oriented Convolutional Neural Network (KCNN) for Causal Relation Extraction in South China Sea SCS conflict issue, which are supervised by Dr. ANAZIDA. In short, what my project doing is extracting the causal relation from the South China Sea conflict by applying KCNN method. In my presentation, I will divide them into 6 sessions, which is Introduction, Literature Review, Research Methodology, Research Design and Implementation, Results Analysis and Discussion, and finally, Conclusion. For introduction, first of all, I would like to introduce what is causality. Causality is the relation between the cause and effect. So it is very important as it can help in explanation, design making, and event prediction. How causality can help us in this importance? It allows us to understand the pattern and learn the correlation of event happen. For a simple example, we all know that one of the causes of tsunami is earthquake. Their causal relation is the cause is earthquake and the effect is tsunami. This helps us to explain why the tsunami happened, and in decision making, it helps government or developer to implement prevention such as earthquake or tsunami detection and alert residents to evacuate the area or build a vertical barrier to decrease tsunami impact. Next, I would like to introduce the case study of this project, which is South China Sea conflict. This conflict is due to overlapping of territorial claims in South China Sea area. There are several countries involved in this conflict such as Brunei, China, Taiwan, Malaysia, Indonesia, Philippines, and Vietnam. This is because this area is rich of resources and costs USS 5 trillion won of the global trade. Let me discuss a little bit of SCS conflict. In 1947, China claimed 9 dash lines in South China Sea area, which includes Pati Island and Ppresentation Island. In 1917, Philippines, Malaysia, and other countries claimed Pati Island, and in 1974, China takes the control of Ppresentation Island for Vietnam. Until now, China has claimed about 90% of the South China Sea area. However, China's claim is not approved by all other countries as there is no official claim from the international law. In this dispute, there are some issues happen such as the China detained Vietnam's fishermen in this area, and Vietnam fishermen is caught by the China. Indonesia blamed Vietnam for disputing, and also some cyber attacks such as using the Trojan or malware to in this SCS area. Next, the importance of learning causal relation on SCS issue is the dispute is jeopardize national security and bring loss of money and people. Besides that, learning the causal relation can help the ministry to understand the causal relation easily from the online news article and help them to make the decision that related to the national security. This is because the online news is easy to get and update frequently. There are some challenges in causal relation extraction, which is the human language is compressed and the causal expression is many. Hence, there are some solutions to solve this problem is the challenge, which is automatic to generate the causal word from the machine and automatic extract the causal relation. Hence, in this study, the problem statement is the online news articles are unstructured and too many in the online, and most of the approach such as rule-based and machine learning-based have the limitation to extract the compressed causality well from the natural language text. In this research, the aim is to extract causal expression related to issues on SCS conflict using knowledge-oriented convolutional neural network (KCNN). In this research, the objective have 3 objectives, which is objective 1 to pre-process the data improved by using red annotation tool to annotate and WordNet lemmatizers for base form transformation. Objective 2 To implement KCNN technique to extract the causal relation of an issue from the online SCS news articles. Objective 3. To compare the performance of different types of architecture for KCNN in extracting causal relation from SCS online news by comparing the micro-average F1 score of each architecture. For the scope, the research will take only 100 online news related to South China Sea conflict from the Vietnam, Philippines, and China, such as the China Daily News from the National News Agency. The research will focus on the online news related to SCS from years 2020 to 2019, and it will focus on the causal attributes such as cause, lead to, and result in literature review. As I have discussed the causality and SCS previous, so I will discuss the ascending work. And ascending work for the causal relation extraction have three, which is non-static based or rule based, statically based or machine learning based, and also the deep learning. For the non-statistical based approach, it is a rule-based approach which we need to set some rules or pattern in order to extract the causal relation. However, this method has some limitation where show that the result is low. This is because the human language is complex. Hence, there are many rules need to be set in order to extract exactly the causal relation. Next, for statically based approach, it is machine learning approach which using the existing tools such as NER, name entity recognition, POS, part of speech, to extract the causality. But there are large amount level data needed and many error is found. The next is the deep learning approach by applying neural network to extract the causal relation, and the current work shows that this approach has better results than machine learning because it has better semantic and syntactic analysis to capture complexity of causal expression. I have compared the current existing approach for the causal relation extraction. As we can see, the state-of-art is using machine learning and deep learning approach. Recently, there are some research shows that deep learning and convolutional neural network approach can extract causal relation more accuracy and well performed. Therefore, in this research, I decide to apply CNN method to extract the causal relation. This is the basic architecture of convolutional neural network CNN, which involves some layers such as the convolution layer, pooling layer, and lastly is the output layer of fully connected layer. Next, research methodology. In this study, the method is divided into three phases, which is phase 1, data preprocessing, that related to achieve the objective 1, and phase 2, causal relation extraction to achieve objective 2, and phase 3, comparison different architecture of KCNN model, which related to objective 3. In phase 1, the data preprocessing, all the annotation will be done in the breadth annotation tool to annotate the cause and effect, and also label the sentence with their relation, such as cause effect or effect cause. Then the words will be transformed into the base form by using the wordnet lemmatizer and also to transform them into lowercase. Next, the sentence representation, which to convert the word into the vector. This is because the model will take only the number of metrics as the input data. In phase 2, the causal relation extraction. First, we will construct a word vector automatically, which is collect the causal word from the FNet. And then a KCNN model will be developed by using the PY-touch. In this KCNN model, we will use a knowledge-oriented channel as shown as the picture below, which the word, the sentence will convert to vector by looking up the word embedding, and then it will convert with the word filter that we generate in the point 1. Then the feature convert will send to the pooling layer to extract the max value. Lastly, the feature vector is generated. After we develop the KCN model, we will train it and test with the training data and also the testing data. In phase 3, comparison with different architecture of KCN model, In this way, the max pooling in the pooling layer will change to average pooling. This is used to compare the performance between the max pooling and the average pooling. We want to see which pooling function is more suitable in this dataset. Next, a data-oriented channel is added into the KCNA model to compare the performance with the base model. In here, the data-oriented channel will able to capture the position information, and it will take the whole sentence as the data input. The picture below shows the architecture of the KCNA model that contains knowledge-oriented channel and also the data-oriented channel. In the data-oriented channel is same as the knowledge-oriented channel, where after the convolution layer, it was sent to the pooling layer and then the output layer. In last, we will exchange the max pooling function in the pooling layer for both channel to the average pooling function to see that which pooling function is suitable for the channel to extract the causal reaction in this data. So for the dataset, we are collect the online news from the online that related to SCS dispute from the National News Agency. The picture shown is the sample of the data set or the online news that we collect. And then this picture shows that the causal phases that I have extracted and also annotated by using the black annotation tool. Next is the data distribution. In total, I have collected 192 sentences for this dataset, which contain the relations such as the cause effect and the effect cause. For training data, there are total 152, and the testing data is 39 sentences. So in research design and implementation, there are three phases which we discussed in the research methodology. In phase 1, the annotation of dataset. First, the sentence extractor will put into the black annotation tool, and then the two entity will be labeled as for the cause effect is the cause and effect, and the sentence will label with their relation. For others, it will label as the entity 1 and entity 2, and the relation will be labeled as other. Next, .nnn file will be generated to which store the entity that we labeled just now. Then I will change the .nnn file into the text file, which include the annotation that we annotate with the original sentence. Next, to pre-processing the data, all the sentence or the data we collected will transform into the lowercase and also the base form. For the base form, we're using the WordNet lematizer to lematize them. Then we remain the position in text for the entity 1 and entity 2 only. Next, the label will be extracted into a different file which is named as the label.txt. Next, for the sentence representation, this is the word embedding that pre-trained by using the English Wikipedia, and I download it from the link below. Then you can see here the word and actually the behind is the is better, and then for our word we have found it from the word embedding table. Then we attach it with a index number. Then the index refers to the index tag in the new word embedding table. Because the word embedding table is too big for our study, then the word we found we will extract into a new word embedding table. Then the index is corresponding to the vector that we store. Next, in phase 2 causal relation extraction, first of all, we need to generate a word filter bank, and the causal keyword is collected from the friend net. Then from the friend net, there is a lot of friends contain different category of English, and there's some causation or causation scenario or other friends that start with the cause will be used to collect the lexical unit that is actually the causal keyword. So for the causation, the lexical unit is content of because of, bring about, and cause. The rest is all have the meanings of the causal keyword. So next, we will develop the KCNA model by using the PY and it contains 4 layers: embedding, convolutional, pooling, and output layer. Then in this KCNA model, we will use only the knowledge-oriented channel in the convolutional layer. After that, we are using a software classifier to classify the causal relation or not causal relation. After that, we will train the KCNN model with 152 training data and train with 100 ePulse, and each base size will be 20. Then we will evaluate the KCNN model with 39 testing data, which the label is not provided to the model, so they can label it to classify the relation. Next, for phase 3 comparison of different architecture of CNN model, as discussed in the methodology, there are different architectures such as changing the pooling layer and also adding a data-oriented channel. Here, there are 6 different architectures will be compared, and the macro average of each architecture will be compared to find out the most suitable or the high performance for the SAS online news article to extract the causal relation extraction. Next, for the result analysis and discussion. For the objective one, all the sentences extracted have been annotated and labeled with its relation. All the work is transformed into lowercase and also the base form, and they are converted into the vector by looking up the work appending table. For objective 2, 452 causal keywords are collected from the front net, and the picture shows the keyword we have collected. Next, the development of the KCN model. A KCN model has been built, and the table shows that the result of the KCN model. From the result, we can show that it has a better performance to classify the cause and effect, which cause effect is actually in the sentence the cause is followed by the effect, while effect cause is a sentence that the effect is followed by the cause. The performance for class cause effect is good because the knowledge-oriented channel able to capture the causal phrase such as cause, lead to, and result in. However, for the class effect and cause, the performance is low because there are some sentences contain the because but do not contain the causal relation. This is because some of the sentences that contain the because keyword is more to describing the sentence or the point, but do not contain the causal relation. Next, for objective 3, the comparison. For a better explanation, I have named each of the architecture with the name as shown as below. The KCNN KMax, which is the base CNN KCNN model that contain the knowledge-oriented channel using max pooling layer only. The second KAVG means that the KCNN model with knowledge-oriented channel only then using average pooling layer. For third KCNN KMax underscore DMax is the model with knowledge-oriented channel and also the data-oriented channel, but both channel with using max pooling. Then for the rest, we will exchange the max pooling layer to the average layer consequently with the knowledge-oriented channel first, then we change the data-oriented channels with the average pooling layer. And the last model is both channel is using the average pooling. This table shows the summary of each architecture result in the F1 score. From the table, we can see that the KCNN underscore KAVG is actually have a better performance than the base model, which is using the max pooling layer. This is because some of the causal keyword in the sentence is not in between the cause and effect. Hence, the knowledge-oriented channel cannot capture the keyword properly. Therefore, the average pooling layer helps to refine the feature capture for the sentence because the average pooling function captures the average value from all the words and keep the information of less important words, while the max pooling layer will capture the most significant words and ignore the other words. Then for the third architecture, which has the data-oriented channel, it shows that it have the better performance when compared to the base model. This is because the position feature extracted from the sentence can help the model to recognize the causal relation more accuracy because there are some keyword is not lying in between the cause and effect, while the knowledge-oriented channel is taking the words between the two entities only as the input data, while the data-oriented channel is taking the whole sentence as the input data. Hence, it can capture more important information that have been ignored by the knowledge-oriented channel. For the fourth architecture, the K average and D max, it shows that it has the highest F1 score for the class cause effect, and it has a better micro average F1 score when compared to previous three architecture. This shows that the knowledge-oriented channel with average pooling layer can work well with the data-oriented channel. And from the last two architecture, we can see that the data-oriented channel with using the average pooling layer can improve the performance also. And it can also show that the knowledge-oriented channel with the average pooling layer can work well with these data-oriented channels, because data-oriented channel with average pooling layer have increased the performance, but when with the knowledge-oriented channel that using the max pooling layer, the performance is increased not much. Hence, in the last architecture, the knowledge-oriented channel with average pooling layer and data-oriented channel with average pooling layer have achieved the highest micro average F1 score when compared to others architecture. In short, the most suitable architecture for this dataset is the KCNN model that using knowledge-oriented and data-oriented channel, with both channel using the average pooling layer. In conclusion, the achievement of this study, the data collected have been annotated, transformed to lowercase and base form, and eventually convert to beta. Then, a word vector that contain Q phases of the causality relation have been generated. A KCNN that used to extract causal relation from SCN's online news article have been constructed. And lastly, the most suitable architecture of KCNN model for the SAS online news article have been found by comparing the micro average F1 score and of each architecture, which is actually the KCNN model with knowledge-oriented channel and data-oriented channel, and both channel using the average pooling layer. In this study, there are some constraints that limit the performance of the model to extract the causal relation, which is the model cannot extract the causal relation if the cause and effect are not in the same sentence. For example, the first sentence, there is earthquake happened in the sea. Then in the second sentence, as a result, the tsunami happens. From this simple example, we can see that the cause and effect is separated into two sentences, where our model would take only one sentence as the input. So this model is not able to extract the causal relation that the cause and effect is in different sentences. Next, the model cannot recognize the negative causal relation, such as not because, is not caused by, and also the condition sentences that contain the causal relation. The conditional sentence means that, for example, we cannot skip a class, because if we skip the class, we cannot get a good grade. From the sentence given, this is a hypothesis that haven't occurred yet, so this will not consider as a proper causal relation. Next, the causal sentences are extracted and annotated manually, which lower the efficiency of the work. This is because there are a lot of online news articles collected, but some of the articles do not contain the causal sentences of other relation sentence. Therefore, we need to filter it one by one and read through them, and after that, the sentence extracted need to manually annotate by using the annotation tool. Next, for the suggestion for improvement and future works, we can improve the selection and annotation of causal sentence from the online news article from the manual to automatic, and then improve the model to able to differentiate the positive and negative causal sentences. Lastly, the information such as country or time can be extracted also to make the extraction become more informative. That's all for my presentation. Thank you.